Hello everyone, welcome you all for the lecture series 2 about the control system subject. In the second series, we are going to deal with the time responses, and today also we are going to discuss about the time response concept. So in this, first we have to know what about this time response and how we are classifying it into various states. The time response, we can explain it as if the output of the control system for an input varies with respect to time, then it is called as the time response of the system. So from the graph, we can able to see that we are taking the x-axis as time and the y-axis as the response, and we are getting some curve values. In that, we are dividing into two states. One is transient state, another one is steady state. And we can express it this states by means of mathematically, that is C of t, which is equal to C of TR of t plus C of SS of t. Here, TR of t is corresponding to the transient response, and SS of t, which corresponds to the steady state response. So let me explain this transient response as well as this steady state response in detail in this slide. After applying the input to the control system, output takes certain time to reach the steady state value. So in this graph, you can observe that point from 0 till some time period. Let me take this time as t1. So from 0 to t1, it takes a certain time, and it reaches the output will reaches the value near to the stable one. So this period, which we are naming it as transient state. So the output will be in the transient state till it goes to the steady state. Therefore, this particular response, what we are happening in the transient state, which we are naming it as a transient response. And we can also write this transient response in mathematically, that is the transient response will be 0 for larger value of t, and the value of t is infinitely, and practically it is the 5 times constant. So the expressions what we are using for this transient response is if t tends to 0 with the limit c tr of t, that is the transient response time, which is equal to 0. Next we are entering into the steady state response. So once the transient response is getting over, that is when the time period after your t1, it almost reaches the steady state values. So this steady state response, we have the part of the time response that remains even after the transient response has 0 value for the larger values of t is known as the steady state response. The transient response will be 0 even during the steady state values. So once it enters into the steady state value, the complete transient response value will become 0. So this can be easily understood by means of this example also. So now we have some idea about what the transient state as well as the steady state. Now it is also easy to understand with an example of ball. So let me explain this question first. When we pick a ball in a setup as shown, that is the ball is in this state, that is the state 1, when time equal to 0, the ball bounces a few times due to its kinetic energy and then settles. So you can able to see this ball is bouncing for few times, and this magnitude gets reducing, and after particular time it got settled at state 2. The response when the ball is still bouncing is the transient response. That is when the ball is bouncing, that responses we are naming it as the transient response. Once the ball gets settled, that is in the state 2, the ball gets settled in this place. These place we are naming it as the steady state response. It is the steady state. The output will be in the transient state till it goes to the steady state. So we can expect the output in the transient state as well as the steady state value. But once the steady state is reached, the transient response will be 0. So same way, what we are explained with this graph, which we can able to relate with the examples of this ball, how it transferred from state 1 to state 2. It has some bouncing state, that we are naming it as the transient state, and after some bouncing state, it gets settled, that we are naming it as the steady state response. Next, the order of the system. Order of the system is given by the maximum power of S in the denominator in the transfer function, that we can name it as first order or second order system. Whatever the maximum power of S in the denominator, that will be the order of the system. We are concentrating on the first order as well as the second order. In the first order, it is defined as the input output relationship, and which is a first order differential equations. The order of the differential equation is the order of the highest order derivative present in the equation. Next, we are dealing with the second order. So the maximum power of S is 2 over here. The order of the control system is determined by the power of S in the denominator of its transfer function. For second order, the highest power is 2. For the first order, the power of S is 1. So I hope you have understand this time response as well as the order of the system. So let me explain some other topics in the upcoming videos. Thank you.